So here, these are going to be the notes for 4.1.1. These are going to be the last notes that we need for our linear functions essential skill. So on today's agenda, there's that link to the images. The images themselves are 6-word problems. So instead of us spending time in class for you to feverishly try to copy down the word problems, I wanted to have them ready for you. Plus, I wanted you to know that you could go back to your agenda and find them again when hopefully you use this to review for your upcoming test. So at this point, what I would like you to do, I would like you to read number 1 to yourself very carefully. I want you to think, what type of information in this problem do I absolutely need to know? Because what we're going to do is we're going to pull it out of the question and we're going to organize it for ourselves. So read carefully. See if you can figure out what is it that we absolutely need to know from question number 1 or from statement number 1. So I know I need to identify the variable. So highlighted it. Let's pull it out of there. So X is the number of heather bushes. Anytime the variables are defined for me, that's pretty big information. And the other piece of information with defining my variables is the number of rabbits. All right, let's write that one down also. So Y is the number of rabbits. Okay. All right, let's look a little bit further and see, is there anything else we absolutely need to go through the whole thing and just kind of pull it out and put it off to the side so we can use it whenever we have a word problem in math? No doubt, we want the stuff that has numbers in it, for sure. So let's go ahead and pull that out as well. So I know I need that. So Y equals 4 plus 3.8x. Okay, so I think I've pulled all of the information out of it, but I have no idea what I'm supposed to do with it. So I do believe there's only one other thing that I need to determine, and that is, what do they want? So if you take a look at the very last sentence, we're trying to figure out what 3.8 represents in the equation. All right, well, let's look at the equation. And another great reason why we pulled it out, so we can kind of mess around with it a little bit now. So I want you to inspect that equation. We have Y equals, okay, that's good, looks like equations we've been doing, 4 plus 3.8x. We want to know what the 3.8 represents. So I think what we have to decide is, what is 3.8? Is 3.8 the y-intercept, or is 3.8 the slope? So I'm going to identify, and again, the dead giveaway is there's an x connected to it. This is slope. So here's what I want to do. I want to kind of go back to what we did previously. So we had a problem about Erica planting a tree. We were given that information in context. We even had to deal with the big race finals. That was also in context. If you recall, the slope in context helped us realize how to label the x and the y-axis. I want to see if I can write down what I think the slope is in context, because I think it's going to help me describe the slope. So I'm going to take my 3.8, and I am going to write it as a pretty big fraction. I'll get rid of the extra stuff if I have to. And I'm going to put a 1 underneath it, because every single number can have a denominator of 1, every single one. I remember that the top of slope is the change in y. So the y variable goes up there. I also remember that the change in x goes in the bottom. So I think what I'm going to do is I'm going to take the variables that are defined for me that I pulled out, and I'm going to put them where they belong. So change in y, I'm going to go back to my list over there on the left-hand side, and they told me that y was the number of rabbits. So I'm going to put 3.8 rabbits on top. We'll do the same thing with the x. Well, x was identified as the number of heather bushes. So I would say this is 1 heather bush on the bottom. So again, reminiscent of what we did with the big race, but just kind of in reverse. So we'll get rid of that extra bit of the fraction bar. Just remember, it's y on top and x on the bottom. Using this fraction in context, I think that you and I can write down what slope means in context. So here we go. 3.8 represents all right, slope is a rate. So we need to use a word that identifies us for this to be a rate. It's either an increase or it is a decrease. Well, if you take a look at this, 3.8 is positive. So I think that this is an increase. So this represents the increase of, well, the y value on top, increase of rabbits, so I've done with the top of the fraction. I want to transition now to the bottom. And I'm going to say for every. That's going to be my transition to get to the bottom of my fraction. For every, now I'm at the bottom, for every heather bush. So here's the format of this thing. And this isn't the only way to write it. This is one way to write it. So what I have here is 3.8 represents the, okay, increase. That's because slope was a positive number. Of rabbits, well, rabbits was the y. Increase of rabbits, that's my y. For every, this is my transition. This gets me from the top of my fraction to the bottom. For every heather bush. Well, heather bush is the x. So what I did was I wrote out my fraction. I know that the y goes on top and the x goes on the bottom. And then I used that fraction to try to write out my sentence explanation for my slope. Okay, so take a minute. Read number 2 carefully. Know the things that we need to pull out. They're the same type of things that we pulled out in the first one. We need to know what x represents. We have to know what y represents. We need the equation for sure. And we have to know what they're actually asking us. Now, half the battle with any of the stuff that you do in any of your classes is knowing what the question is. Okay, so I went through and I identified all the stuff I would need. I know what x represents directly from the question. I know what y represents directly from the question. And then I wrote down the equation. Because again, numbers are an indicator. In a math class, you got to have the numbers. Then I went through and I boxed the question. So they're really asking me about the number 1.14. So I inspect the equation and I try to determine what 1.14 is. But there's a dead giveaway again. 1.14 has an x attached to it, which means that's slope. So I identify my slope as 1.14, and I'm going to put it over 1, big long fraction, and then start sliding in the information. remember, y goes on top. So this is 1.1 for sick days each year. Over 1 pack of cigarettes smoked each day. Okay, there we go. I've got my slope. Remember, y on top, x on the bottom. Now, like we just did on the previous slide, why don't you see if you can write out the explanation for this? You can follow the same format. So we would say that 1.14 represents okay, it's positive, so we're going to say increase. The increase in sick days per year. So we're just pulling it straight out of the fraction. All right, we've got the top. Now let's transition to the bottom. For every pack of cigarettes, now we're in the denominator. So for every pack of cigarettes, smoked per day. And that is my answer to explain the 1.14. So looking at the third one, see if you can do the whole thing. We want to identify x, want to identify y, want to write out the equation, want to see if we can describe it. Okay, so check yours against mine. I went through and identified what x was. I identified what y was. I wrote down the equation so I could pull some information out of it. They did ask me about the 1.6. Well, in this case, 1.6 is the slope, but there is a negative sign in front of it. So because there's a negative sign in front of it, then that means that there is going to be a decrease in the y value. So basically, the longer somebody spends on social networking sites, this equation says they're going to have fewer dates in a month because of it. So if you look carefully, the question looks exactly the same, except at the very end, we're asked about 4 instead of the 3.8. Okay, so let's take a look at the equation. Same information we had before, except 4 now, that's the b, which we know is our starting value. Okay, let's think about how this connects if we were going to graph this. We know that the starting value helps us find the y-intercept. We know that a y-intercept is always 0, something. In this case, the number we care about is the 4. So it's 0, 4. Okay, so that should help us a little bit. Additionally, we know that every point is an x, y. So the 4 represents the y value, and the 0 represents the x value. Now, we don't say that there is an increase or a decrease. Remember, we only use those when we're talking about a rate. So a slope, things are growing or changing over time. So in this case, I think we just need to flat out say that the 4 is the y value. So let's say that. So 4 represents all right, y value. Well, the y value is the number of rabbits. So 4 represents the number of rabbits. Okay, those are my y's. Let's transition to the x. When, okay, well, the x value is 0. So when there are 0 x's, 0 heather bushes. When there are 0 heather bushes. So basically, in the beginning, before Joe Kim put any heather bushes in his yard, he already had rabbits. Kind of sounds like he's fighting a losing battle against them. Well, they were there to start with. So, my quick little explanation on this. 4 represents the, and I'm going to go straight from the beginning here. 4 represents the number of rabbits. That's y. When, that's my transition. Now I'm going to the x. There are, now I'm at the x. So this is when x equals 0. And it's always going to be x equals 0. Once you have this one, take a look at question number 5. Notice the very strong association between 5 and question number 2, except you're being asked to determine a different number this time. So take a look at this and see if you can answer number 5. So while you are working on number 5, I'm also going to work on it so you can take a look up while we're working and see if you got the same thing. And then once we get to question number 6, I want you to see if you can do the whole thing yourself. Now again, just like with slope, this isn't the only way to say it. Another way to say it is, if somebody is a non-smoker, so they don't smoke at all, then the expectation is that they use 6 sick days per year. So, no cigarettes, 6 sick days. Okay, so let's see here. We know we're being asked about 30, so that's our starting value. We know that that can be written as a y-intercept, or at least it helps us find the y-intercept, so 0, comma, all right, 30. Remember, that's an x and that's a y. All right, so 30 represents the y value, the number of dates per month. or number of dates in a month. When 0 hours are spent on social networking sites. And again, this can be said a whole bunch of different ways. So let's say that somebody, so another way to say this, let's say they spent no time or no hours at all on any type of social networking site. Could be LinkedIn, could be Instagram, could be Facebook, could be Twitter, could be Snapchat, could be on anything. If they spent 0 hours on any of those things, the expectation, based off of this equation, is that they would have 30 dates in a month. That's basically what this says. Again, not only one way to say it.